So, hello everyone. This is Akash Shilus. I'm currently in my third year IT department in MIT, and I'll be presenting my cloud project here. And so let's get started. So the problem statement for the Cloud Essential project, which is given to us, is something like this. Like John is a newbie to the cloud computing domain. He's exploring AWS and he wishes to explore more about VPC and its resources, and he wants to create them in the AWS platform. So he requires our assistance in creating this VPC. So we're basically exploring VPC and its resources and how this is helpful in this world of cloud computing. And there are various subparts for the same. They've given us the guidelines of how to go about with this problem statement. Right? We need to create VPC, associate elastic IP address, explore various resources of VPC like Internet Gateway, NAT Gateway, Subnet security groups, launch an gateway so that Internet access is provided, introduce public subnet and private subnet as well, define the security groups with appropriate inbound rules, and ensure proper routes and corresponding route tables, and also make use of network ACLs for controlling the inbound and outbound traffic in the VPC. So we'll be coming back to this page again and again to check that we have covered all these criterias. So to get started, what is a VPC? VPC is nothing but virtual private cloud. So the service, it is a service which helps us to launch AWS resources in a logically isolated virtual network that we define. And we do not want in the entire internet to get exposed to it, right? So we are creating a separate network, separate isolated virtual network where we can do our own manipulations among ourselves. So this VPC helps us to host a simple web application and helps us to back up important data and also helps us to host multi-tier web app. So this was about VPC, and first we need to create a VPC in order to start exploring its resources. So let's just quickly switch on to the AWS console. So I have opened my AWS console here. So here we have VPC, this virtual private code. We'll move on to that. So here we can see all the VPCs which are present. So one VPC is already created by default. So we need to create a new VPC here. So click create VPC and write your VPC name. So I'll just give the name as project VPC, and this is the we are giving the manual input. So the IPv4 CIDR is nothing but classless inter-domain routing. So IPv4 CIDR will fall in the given range. So we'll give it like this. See, this means that 16 bits will be allocated for our VPC purpose. Right? And tenancy is nothing but if you want a default tenancy or if you want some dedicated path for the tenancy. So we just leave it with default. So now we can create a VPC. And now we can see the message which is popped up here, which says you successfully created your VPC and project VPC. So if you go to your dashboard, your VPC, we can see that our VPC is present in this project. VPC is created and it is running in the dashboard, and the state is also available. Okay, this is the status of our VPC. So this was the first part. And the second part, if you see, it is will be coming back to associate the internet gateways, subnets, route table, etc. with this VPC. The second part which we need to do is nothing but associate an elastic IP address with it. So you know what is an IP address? We already know. But elastic IP address is nothing but a public IPv4 address which is used for dynamic cloud computing. So if we encounter any failure of any instance, for example EC2 instance which runs in our VPC, if we encounter any failure of that, we can quickly remap the address to another instance in your VPC. Thus, we can come over this failure. So it can also be used to associate with an instance. So how do we create this elastic IP address and how do we associate it? So for now, we'll be creating this elastic IP address, and we can associate it only after we create some EC2 instance, or we create some NAT gateway in our VPC. Only then we'll be able to associate it. So for now, let us just create a elastic IP address. So as we can see, there is no elastic IP address for now. So we need to create one. So this is the border group or the region which you say. So we can just click on allocate. So it will all automatically allocate a IP address. So once we create this NAT gateway, or once we create the EC2 instance, we can click on this actions and then associate elastic IP address. Right? So once we do that, we can associate it with our resources which is present inside the VPC, like NAT gateway, etc. So for now, I am just leaving it with allocating the IP address. I am not associating it now. I will be associating it at the end of the session. So we have done this one. It is associating an IP elastic IP address. So the next one, next task which given us is to explore various resources of VPC, like internet gateway, NAT gateway, subnets, security groups, etc. So let us create an internet gateway. So internet gateway, as we know, it provides access for the VPC to the outer world, that is to the internet. So without it, we cannot connect to the internet. So we have so we have an option called internet gateways here. So let's quickly create a internet gateway, right? So this is one default one. So we'll create an internet gateway. So I'll just give the name as project IJW, and then I'll create a internet gateway. And we can see that the state of this internet gateway which we have created is detached. Means it is not attached to any VPC. It is just a solo or independent one. But there is no use of creating such internet gateway, right? So we just attach it to a VPC which we have already created. So select VPC, we attach it to this, and we'll attach this internet gateway. So now if we see the pop-up window, you will get to know that the state is attached now, right? So we have created this internet gateway. So that is one resource which we covered now, and the other resources will be exploring it. So the resources of VPC are as follows: subnet, internet gateway, security groups, and NAT gateway. We also have we also have NACL separately, which is used for controlling or denying the traffic. NAT gateway will do this at last, because you need to uh, associate the subnets, create the route tables, etc., and then only we can create this NAT gateway. So if you will directly go to subnet, and before going to subnet, we'll just see the outline architecture of what we are actually doing, right? So this is the overall VPC. The outer border is nothing but the overall VPC, and this is the internet gateway which we have attached to this VPC. So through this internet gateway, data can come in and go out of the VPC to the internet and vice versa. So that is what we have done. So now what we have to do is we have to create two subnets. So subnet, I mean two subnets, like public subnet and the private subnet, and also create two route tables. So route tables, it has rules of how traffic will flow, right, inside the VPC. So you will have servers route table and database route table. Server route table is attached to your public subnet, whereas your DB route table is attached to your private subnet. So that is what is shown in this diagram. And inside each thing, you will be creating some machines if you want to, right, for administrators or anyone who wants to uh, create a website or something, create a server or something. We create machines inside these things, right? And we also attach NAT gateway, and also NACL along with security groups as well, which will be seen in the upcoming slides. So this is the overall architecture, overall outline of what we are designing and what we are creating in this AWS cloud platform. So moving on to subnet, it is a logical subdivision of a larger network. So we must have already heard about this in our computer networks topics. So IP address of all subnet in a particular network is same. It will have the same prefix. So same means the same prefix. And a public subnet basically is used for web servers. So these are two types of subnets, right? Public subnet and private subnet. So public subnet is used for web servers and it is exposed to the internet, whereas private subnet is used for database and app servers. So now we'll be seeing how to replicate the same in our AWS console. So we have subnets here, click on that, and we have the default subnets already created. So we need to create a new subnet. So to create the public subnet, we'll select the VPC. So subnet settings, you need to provide the name here. So this is the public subnet which we are creating. Availability zone, we'll select the first one. Then IPv4 CID block, we'll give it like this. In 10.0, so 24 bits will be allocated, right? So we can create the subnet, public subnet. Now if we see, this public subnet is created, and these are the different things like flow logs. Flow logs, it will for now there are no flow logs present. Route table, we need to edit the route table association later on. Network ACL which is associated, tags if any present, classes and reservations. So these are things which can be explored more in detail. So we have created this public subnet and we can see the status of that and the VPC to which it is attached. Similarly, you need to create a private subnet as well. So we select the same VPC, private subnet, availability zone. So this will be like this, and we are creating the private subnet. So if we go to subnets, right, we can see both our public and private subnet. And if you extend this VPC, we can see that both this public and private subnet is allocated or associated with your project VPC, which is the VPC that we created. So for now, the subnet part is over. We have created both the subnets. So we saw that public subnet is used for web servers, for web apps, and private subnet is used basically for your database service. So moving on, next one, security groups also along with NAT gateway we'll be seeing at the last. So now we have to concentrate on the route table. So what is a route table? It contains a set of rules which is used to determine where the network traffic from VPC is directed. So we basically create two route tables, server route table and database route table. So according to the diagram, we'll be creating these two, server route table and database route table. And also we have been asked to create a route table like uh, to create a route table and also edit the proper route, ensure the proper routes and entry specifying the traffic moving out of the subnet. So that's why we're creating that. So we'll go to the AWS management console, go to route table. So we don't have any our user defined route table created. These are default ones. So we'll create a route table, give the name. So I'll give the name as server route table, and the VPC, it will be attached to this project VPC, and you are creating a route table, right? So this is the first route table which you are creating, server route table. Similarly, you need to create your database route table as well, and it will be attached to this VPC again, and you will create this route table. Just creating a route table is not sufficient. We can see that in the dashboard we have these two, right? DB RT and server RT. But just creating it is not enough. You need to attach it with your subnets, right? So go to subnet association and edit this subnet association, right? So after editing it, you are associating the server route table with your public subnet, right? So you can save this association. Similarly, go to your database RT, go to subnet association and edit subnet association and link it with your private subnet. So now if you click on this, you can see in the subnet association it is associated with your private subnet, and this one will be associated with your public subnet, right? But this is not enough. You need to ensure the proper routes are there for traffic to flow. So for that, right, you need to edit the routes. Go to routes and you need to edit the routes. So you are adding a route. So we'll specify 0.0.0.0/route. This means that traffic can flow from anywhere, any internet. And the internet gateway, this is the gateway which we designed few minutes back, and we are saving the changes. So we are creating this route. Similarly, if you go, you can change the same for your DB route table as well. So add route, same internet gateway, and save your changes. So now if you see your routes, it is changed, right? The destination, local, etc. And the internet gateway is here. The destination is 0. It can flow, traffic can flow from anywhere. Target is at this internet gateway. It will pass through that. So for both these things, this is the so even for this you can see the same thing. Okay, so for both these things, we have edited the route, created a route, and also associated a subnet with it. Okay, so major part of this project is done, and now we have to create EC2 instances, attach NAT gateway, and create security groups, etc. So all these things are yet to be done, and also do NACL groups. So moving to the next part. So we've explored these NAT gateway, create internet gateway, subnets, etc. But NAT gateway security groups we need to do it. So we have also introduced a public subnet for web server and private subnet for backend server like database server. And yeah, we have ensured proper routes and corresponding route table entry specifying the traffic moving out of the subnet. So now we'll go and quickly create a network ACL for controlling the inbound and outbound traffic. So what is a network ACL? We just it allows and denies the traffic to and from the VPC, and it is stateless. That is, it does not contain the information. It does not retain any previous information. Right. So it denies and allows the traffic. That's its main, and it has inbound and outbound rules. Inbound rules refers to the rules that put a check on all the traffic coming from outside, right, into the VPC, and outbound going outside from the VPC. So that is the network ACL. So how do we create it? So we'll go to network ACL, and you need to create a network ACL. So project NACL, will give the name, and the VPC is your project VPC, right? So we are creating a network ACL. Now if you see, your NACL is created, project NACL is created, and we can edit this inbound rules. So we'll go to this and we'll edit this inbound rules. So we'll add a new rule number 1. So for all the SSH port number 22, we are creating a rule number and we are allowing that, right? So you're saving the changes, right? Again, we also want the same to be done for HTTP, which runs on port 80 as well. So we can add another rule called rule number 2, for your HTTP, yeah, we are allowing that as well. So this is the inbound rules, right? So if you go to inbound rules, we can see that according to rule number 1 and 2, all these things are allowed and all other traffic are denied by default, and these two things we are allowing: SSH and HTTP traffic across this port range specified. So this is how we have changed the inbound rules. Similarly, we can go and change our outbound rules as well. So if we click on outbound rules, from this, all the other traffic, how it is going. So if you want, we can go and add a new rule. Similarly, save a change. So that is how we create a outbound rule, right? But for this, we do not require any outbound rules. We can this can go anywhere, right? Towards the internet. Only while coming, we need to ensure security. So yeah. So that was all about NACL, which allows and denies the traffic. And now if you see this, we have created NACL and control the inbound and outbound traffic in the VPC. So uh, just to show the example, I'll just create one outbound rule. Uh, like it is denied everything. So I'll just create again, because HTTP and TCP we have allowed it. SSH. So I'll do the same here. So edit outbound rules, add new rule, HTTP, again save changes. Right, so both inbound and outbound rules, you can see HTTP and SSH are added and they are allowed. So that is how we have made use of network ACL, and we have controlled the inbound and outbound traffic in the VPC. Now we need to go to your NAT gateway, and so before going to that, and we need to ensure that internet access provided to the private resources. So NAT gateway is nothing but it's a network address translation gateway. An instance in private subnet can connect to services outside your VPC. Right? So whatever is there present in your instance is a present in your subnet, private subnet. Even outside the VPC, it can connect to it. So that's the main use of NAT gateway. And we'll just see how to create a NAT gateway. So move to this NAT gateway here. Create a NAT gateway. So project NAT. The subnet we are associating with our private subnet, because instances in private subnet need to connect to outside of VPC, right? Let it be public and elastic IP address. So this is where the IP address which we created, is being used. So this is what we created earlier on. So we are allocating that IP address, right? And we are creating this NAT gateway. So now we can see that this NAT gateway, so the state is pending. It will take a few minutes to reload, right? So we just wait for it to uh, go to the state. So if you see, we have refreshed it and the state is now available. And also the elastic IP address which we have allocated, it has been allocated for this NAT gateway. So we have created NACL, we have created NAT gateway, we have created IGW, Internet Gateway, we have created subnets, we have created route tables which are associated with the subnets. We have also edited the routes, and all these things have been attached to our VPC. And we've also created elastic IP and attached with our NAT gateway. And one more thing to note is elastic IPs can also be associated with the EC2 instances which are present in our VPC. So to explore that, you need to create a EC2 instance. So So why are we doing all these things? Why are we creating this VPC? To have a logically defined isolated virtual network, right? This is for only among us. So only whom I permit will be able to see, right? So a private network is created, virtual network is created. So we can run servers on inside this VPCs. So for that, we'll just go and explore this EC2 instance, because without application, it is not advisable to show the presentation. So the EC2 instances, we are going to create this inside our VPC, not just on the whole cloud network. So we'll go to launch an instance. So EC2 instance. So this is the name, and we'll select the Windows Microsoft thing. And keypad is basically used for security purposes, right? But here as we are not involving in any bigger motive of doing it, just for the practice purposes, or I mean for the project purposes, we'll just go in with the default, or else we can create a external keypad and do it, right? So network setting, this is where we need to, so this here all these things are automatically enabled, and we do not want it. We need to create a EC2 instance inside our VPC. So just we click edit. So the VPC is our project VPC, and the subnet is your public subnet. Let us give it that. And auto assign public, no, we are going to enable it, right? So this is how you are creating it. So this is the way we edit the network configuration, and we are launching the instance. So now if you see, this instance has been successfully launched, and if you go to your dashboard, you can see that this instance is running. So for now, this instance state is pending. So once we refresh it, or once we wait for 2 to 3 minutes, we can see that this instance state will be available and it will be running. Okay. So this is the host name, this is the instance ID, and the private IP address. So when we go to security groups, right? So, so now if we refresh it, we can see that this is running. So if we go to security groups, you can actually create a security group, right? So that is also one part. Right? You have to create a security group, define security group with appropriate inbound rules. So we are doing that. So the security group is I'll just give the project security, and it allows SSH and HTTP, which is the inbound and outbound rules for all the users, which we have already defined, right? SSH and HTTP, and the VPC is so I'll just do it again, like security project. I'll just give the name as project security group, and description allows SSH and the HTTP access. And this is the default VPC which is there, so we can add a rule like HTTP. It will get add rule. Again SSH, we are again adding the rule for that, right? So that is the thing. So outbound rule, similarly again HTTP add, and for SSH also we are adding the same thing, right? So we are adding the rule. So now we are creating a security group. Okay, before that you need to uh, complete the CRDI block. Prefix has to be listed, right? So we can list the conventional all the traffic thing, and we'll just check if we can create it. Yes, so we are able to create the security group, and if you check now, all these inbound rules will be specified, and along with that your outbound rules are also specified, and there are three permission entries. So this is how we have created a security group for our VPC with inbound and outbound rules. So now if we check this thing, we created an Amazon VPC. It is displayed on the dashboard, and we have associated elastic IP address with it. We have explored various resources of VPC like IG, NAT gateway, subnet security groups. We have also launched a NAT gateway, and we have also associated the elastic IP address with it. We have created public subnet and also created private subnet, and defined the security group with appropriate inbound rules. And we have also ensured proper routes. We have created route tables, server route table, DB route table, and ensured proper routes for them, and also specified the traffic moving in and out of them, and also associated subnets with them. And we have also made use of the network ACL for controlling the inbound and outbound traffic. So all these things we created: VPCs, subnets, private subnets, route tables, internet gateways, elastic IPs, NAT gateways, network ACLs, and lastly, we've done this security group, right? The project security is what we have done, allows SSS and HTTP access. So this was all about this project where we have created a VPC, ensured a new private network, and also we have also started our EC2 instance inside this virtual private cloud. So this is basically a server which is running inside our VPC for our own purposes, right? So this was one application of their cloud which I learned. But along with it, I also learned a very another exciting thing is called Amazon S3, which I would like to create a short demo here about Amazon S3, where you can host a website. So I have, as part of this project, I've created a website using HTML, JavaScript, and CSS, and would like to show how we can use Amazon S3 and host it in our website. So that is one extra add-on which I'm doing for this. So here we hope we saw all these things. We have created this architecture as a route table, and this is the additional Amazon S3 storage service in AWS, and it can be used to host website and store resources. So we can go to S3. We can create a bucket. So we can write it as project online shopping because my thing deals with online shopping, right? So project online shopping. So this is the AWS region. ACLs are disabled, but we need to unblock all the public access because it should be publicly available, right? So we can create the okay. We can now create the bucket. Okay, we need to check this checkbox as well. So we can create the bucket now. So when we go to buckets, we can see that this bucket is available, which we have just created, right? So inside this bucket, we need to change the property so that we can host, right? So we go to static website hosting, edit it, and we enable it and save the changes. So the default thing will be java 11.html, which I had done. So this is the property which I've edited, and permission bucket policy we need to edit, right? So for that, I have a bucket policy in my I have saved. So I'll just copy this and I will paste it here. So here, so this is the name of the bucket, right? Project online shopping. So I'll just save the changes. So here we have successfully edited it, and it is also publicly accessible. So now the last thing which you need to do is upload the files. So click on this bucket and click upload. and you can now add the various files which are present. So I have all these files present here. So I'm just clicking them and clicking open. So I have uploaded all these files. So I click on upload. So it will be slowly uploading all the files. So once done, we'll be able to see our online website, because all these things are stored on the storage service of AWS. So hence this will be publicly accessible to everyone, and we have also changed the settings accordingly, right? So this is the destination. So we can close this, go to our buckets, properties. And if we go here, we'll be able to see our website. So this is the website. So this is the website which I had created. So I have hosted it on Amazon S3 with stuff. So you can register and log in and order items from this. So we can register, right? So some mobile number and some password. So I like to subscribe for mail as well. So I am clicking submit. So this brings us to the login platform. So again, you have to click the write the password, and if you so, it will take you to the shopping website, right? So it takes you to the shopping website where you can see all the t-shirts and you can order. So this was all about website, how we store the website inside our Amazon S3. So that is what we have kind of constructed a VPC, subnet, route table, NACL, security groups, everything, and also created an EC2 instance inside our VPC, created NACL, etc. And we basically covered everything which is present. And as an add-on, I've also created my own website and hosted it in Amazon S3, and I've showed the demo for the same, right? So all these things have been created. So that brings us to the end of this presentation. So this is again Akash Shelf signing off. So thank you for listening to this presentation.